thank you very much. Thanks for the introduction. I hope you can hear me well. As you can see, I brought some, let's say, hands-on samples with me. I will show you some of our 3D printed products. Oh, thank you very much. All right, let's start. So, thanks for joining us today. Any guests related to boat building, shipbuilding here today? Just a small hands up would be nice. Thank you very much. Okay, so I can, make decision on how I set my wording right. I would like to thank Mr. Christoph Stöcker for inviting me to speak here today. It's a bit of a catchy headline here: Next Generation 3D Printed Boat Parts. I think we have, at least from our experience, some controversial experience with our clients, customers. Most of the boat building industry is more based on solid metal or woodworking manufacturing. So talking about 3D printing is a bit difficult in this setup, I would say. So today I would like to show you some of our working products actually. Who are we? My name is Alexander Schmidt, as you heard already. I'm the managing director and co-founder of Solvit3D. It's a German-based engineering bureau and is located near the Austrian border, right in Winkel, famous ski region over there. And we would like to shape the future of boating together with our clients with the use of 3D printing. So what are our core competencies? As I mentioned, engineering bureau. We do design basically with 3D CAD and 3D sculpting or freeform shaping. We also do reverse engineering, so if a part is broken, if you need some specific design changes on existing parts. And of course, we do manufacturing with additive manufacturing, so we focus on industrial 3D printing. And we also do support, so manufacturing consulting. If you have any questions, how to produce, what type of equipment, what type of material would be best in your specific application, that's something we can also help with. What we are trying to guarantee here is a more or less process and material independent approach. So we would like to provide always the best value for the final part, for the end customer in this case. So that is also something we did in the past. Some of our recent projects over here, we started, so the foundation for our company was set in 2021, so quite new on the market as Solvit3D. And we started actually really with end customer parts, end customer problems, I would say, and tried to scale it up. Nowadays, we focus on business-to-business opportunities, business to distributors, and do also showcase some of the parts on our own online shop. But this is more on a marketing scale to show what is actually possible and what types of material, what types of equipment is used to generate a certain type of product or a certain solution. So as you can see, a lot of our projects are based on specific materials or specific characteristics at least. So it's not always the same machinery, it's not always the same material. And today I have a selection of more or less 10 products to give you at least an overview of what is, for us at least, working in the business and what types of material and equipment we are dealing with. I think the most obvious is the cleat. If you think of boat building, shipbuilding, most of the ships are attached to a cleat, and we do really 3D print custom cleats. So in case you would like to have something with a more polymer basis, we do, for example, carbon fiber filled plastics. This is a nylon basis printed on an SLS printer, company EOS. This also is possible with titanium or stainless steel This is a 316L stainless steel, so rust-free stainless steel. And the benefit for the customer here is mainly to use existing holes, to use the available base on the ship, so he does not need to bore new holes onto his hull. And yeah, also customization, as you can see on this part, we have also integrated some personal engravings. We try to do it a more lightweight way than regular casted cleats. And the funny thing actually is this product was introduced to us because one customer, one client, didn't trust the casted iron cleats, so he was on a hunt for a more technical or stiffer solution. So and we offered him then, of course, the titanium cleat in this case. Next one is the transducer adapter. You can see it also over here. It's basically an adapter which fits an existing probe or a transducer in this case to a hole in the hull of the ship to measure the depth of the water, or some call it fish finder. It's also known as fairing block sometimes. Most of the parts existing on the market do only use their standard sizes, standard probes in this case, and we found one application here where no existing product on the market matched this design, so we generated our own one. Also printed with an SLS printer, in this case PA11. It's a black nylon. It's biodegradable, so it's castor oil based plastic, and basically it's more sustainable, faster than any machined version in this case, and fits on the hull of the customer without any further adjustments. Another product is the railing base. I don't know if you're familiar with the boat design. Mostly you have some fence around the boat, and this is on the lower top of, on the low bottom of the pole or the post, and secures the fence to the ship. This is a very interesting use case on the boat, because we are using here and also the PA11, the black nylon, printed on an SLS printer, and this one separates different metal pieces from each other, so it's a better corrosion resistant solution in this case. And with our 3D printed railing base, we can assure the same stiffness and increase the value for the, or add more value for the end customer, because of the availability also on long terms, and of course then the higher corrosion resistance. Another metal product of ours is this titanium shackle. If you look onto the different metal parts used in the lower sea, most of them are either titanium or a high-grade stainless steel, but all of them are also affected by corrosion and wear on the part. And in this case, it's a small version. We try to use this also because it's lightweight compared to stainless steel shackle. So the use case is you can connect a sail to rope, or use this as a re-guiding solution for regular ropes. And in this case, it's printed with an SLS printer as well. So this is called cold metal fusion process, also available here on the show. Company who did this together with us is Handmade Materials. They invented this process. It's a bit cheaper than selective laser melting in this case, and that's why it's also relevant for our type of customer. So much lighter, much stronger, and as I mentioned earlier, better corrosion resistance. The next product I would like to show you is our tiller mounting. This is also a quite funny story, because I went to a marina, and they tried to find a solution for a regularly CNC machined tiller attachment or steering rod attachment for the boat. So this connects the rudder shaft with the tiller, and we 3D printed it in PA11 with a carbon fiber fill or carbon fiber infill. And in this case, we also handed it over to the customer. And before they went out to the sea, went out sailing actually, they tested it with a hammer to make sure they have enough confidence on the part, on 3D printing in general. So we passed, and the part is mounted on the boat. One of the other things quite interesting is glass, 3D printed glass, or some deck lights, positioning lights. We do this currently with SLA, but during our visit on the show, we also found some newer approaches here. It's a replacement for broken glasses. It's an individualization possibility, and we also use this for quick and fast, or fast and easy restoration solutions for our customers. This is quite interesting. It's a material from Ego's company. It's called iGlide E3. We use it as a rudder shaft bearing to rebuild or to fix broken rudders, and it is more wear resistant than comparable materials. Also printed on an SLS printer. And one of the things I think also is quite obvious, it's an e-propulsion propeller. We are able to design or to provide a modular design, so you can exchange the different blades. You can also modify it from a 4-blade design to a 5-blade design and use it for a much faster and easier replacement if something breaks out in the field. And also printed on an SLS printer. It's a carbon fiber filled product of ours. This I'm quite proud of. It's our recent project. We are planning to introduce it next week on a boat show in the Netherlands. It's a carbon fiber and 3D printed super yacht or mega yacht leather. So we have a modular design. You can exchange certain parts of the leather and create a much faster and stronger solution. It's a combination between PA11 carbon fiber and titanium. And will be launched next week, as I mentioned. And also something maybe not quite familiar for everybody, we also do leather contouring. So this is a raw shaped sheet of leather. You can have it with real leather, plastic covering, with Alcantara covering and all that stuff. So basically here the mold is 3D printed, and we are able to combine the leather with foam, so you have a soft but also contoured look. And the innovation here is that we do not need to stitch it, we do not need to hot stamp it. It's basically the way it looks and feels all the way throughout the life cycle. Our main advantages, I think most of you are familiar with additive manufacturing advantages, but in our experiences, basically the co-creation with customer is very important. We have a lower capital investment, and also the weight reduction is quite a thing for our clients. If it comes to sustainability, the bioplastics, as I mentioned, like here the PA11 on castor oil basis is quite interesting to go a bit more economically friendly, a better lifespan, as I mentioned, with titanium, less corrosion, more durability, and also the digital warehousing. So in case we build any replacement or spare parts, we also store the data file, of course, and will be able to provide it all over the world or in a certain amount of time for our customers on the journey. We also do the design optimization, as I mentioned, but here basically the manufacturing optimization is our main seller, I would say, to prepare the build job right, to orientate the parts right, to upgrade it a bit more than from conventional CNC machining, to get better quality, better solutions at the end. Freeform design, we do a lot of lattice structures, as I mentioned earlier, lightweight design, so you can have lighter cleats, lighter solid parts, and also the customization with personal engravings or textures as used in the leather texturing I mentioned earlier. Of course, additive manufacturing also has its limitations. Here we always try to focus on the added value for our client. So at least we try not to stay on or to stick only on one product or process. We always consider what is the best in our client scenario. And we would like to provide further individual solutions to different customers. And another hint on our own behalf, we are still on the hunt for global manufacturing partners for special materials like the titanium, the iGlide i8. If you are interested, if you have any ideas, feel free to reach out. That's it from my side. If you have any questions, feel free to ask them now. And I would like to say thank you very much for the moment. Maybe we'll see each other later.
Thank you, Alexander. Yeah, if anybody does have a question, I can hand you the microphone.
We want to reach out to you.
Yes. You can send me an email, design@Solvit, or we can exchange business cards later after the show, and then feel free to contact me.
OK, perfect. Thank you very much.
You're welcome.